Yes, friends. So today I'm taking questions based on cuboid and cube. As I promised with you, that next lecture series I'll take on questions based on every what you call solid figures, solid geometrical figures. This is mensuration second either. You can say mensuration second, first was mensuration first, or solid geometry. So questions based on solid geometrical figures I'm talking about. Now, this is my first lecture series on questions based on them. Previous lecture series was devoted to what are the basics of solid geometry. So I have clarified that what is cuboid, what is parallelepiped, what is a rectangular parallelepiped, okay? Or then I talked about what is cube. Cube and cuboid, these are the two topics of today. Questions based on them will clarify what are the basics of them. What is the logic behind all these cubical figures, cubical as well as cuboidal figures, okay? The geometrical figures, this three-dimensional geometry. And simultaneously I'll talk about what is lateral surface, what is their total surface, what is their volume, okay? What is the length of the diagonal. Sometimes the questions are asked. So the two lecture series, this 14th one and 15th one, is devoted to cuboid and cube. Questions based on cuboid and cube, okay, or cube and cuboid, whatever. Now let me first write what are the formulae will be used in case of cuboid and in case of cube. Okay, after that I'll take questions one by one. So from question number 1 to question number 11 questions only are written down here. Now these questions are written in briefly. The reason is why I write down on the board. The reason is that I have not to see the notes again and again, because questions written down here I can read them, can solve it easily, okay, without covering or changing the papers and etc. etc. Okay. So because of that I noted down these questions. They may be briefly one. Okay, please try to just zoom them out, whatever. You can zoom them out and you can just read them briefly that what is given there. But I'll read every question before solving it, so that you can understand that what is question all about. Okay, so that I can clarify that what the basics of this question given. All these questions, as I've told you number of times, that these questions are from students' queries, online queries. In the class studies we have taught a number of lakhs of students, and from there questions are taken, okay, here. Okay, these questions are from students' queries, all right, the class studies and online queries. So that is my simple statement, because I always interact with my students. So from there the queries are there. Okay, so these are questions based on competitive examinations. Because competitive examinations we have taught, I've taught number of for number of years, as well as now I'm taking classes for management and B.Tech students, M.Tech students, okay, BSc, MSc, as well as the students for MBA, MCA, BCA, and BBA. Okay, all those management students, engineering students, as well as now. But these are the questions from previous class studies, okay, from the students who were being taught by me in case of competitive examinations. Okay, almost all kinds of competitive examinations I've taught. IAS, PCS, okay, bank provision officers, double AOs, like GMAT, GRE, SAT, CAT, MAT. CAT and MAT are management subjects by me. Management aptitude test in India. So for them also CAT students and MAT students. CAT is a bit difficult one, but that's not a bit difficult one. Studies questions. Some questions are from CAT studies of the students, then from MAT studies, from bank provision officers, from other queries. Okay, so those questions are taken. Now come to the point. So what is the formulae I am going to use here today? Let me write those formulae. So regarding cuboid, first let me write cuboid. What is the shape of the cuboid? Let me just slow down. Cuboid, the cuboid formulae. Which are the formulae for cuboid? Let me write here formulae or formulas for cuboid. Okay, what is cuboid? Let me take a rectangular shape in the base here. This is a rectangular shape here. Okay, a rectangular shape. This is a cuboid shape. Okay, and this is here cuboid shape. Okay, so this is cuboid. Here we have taken this h. This is length, breadth. This is breadth. Or L, B, L is this, B is this, or L, B, and H. Length, breadth, and height. Okay, so if they are given, then what is the area of four walls? That is known as lateral surface or area of four walls. That is written there. Okay, so first let me take here lateral surface, lateral surface area, or what's known as area of four walls. Area of four walls. What do you mean by this? What is area of four walls? So if there is a room, then there is one length, height, so L into H, area of this one wall. Opposite to that wall, that will also be equivalent to twice LH. This is the longest, length is bigger, height. If height is common, then breadth is smaller, length is bigger. This is longer side or longer wall, we may say. Longer wall, two are the longer walls, two are the smaller walls. If it is a rectangle, roof pipe, or cuboid. Cuboidal shape is rectangle in the base. The floor is a rectangle, roof is a rectangle, all the walls are rectangles. Okay, so six-sided face or six faces, figure, three-dimensional figure here. Height is there, so length into height, and breadth into height. There are two sections here, twice LH, twice BH. And L into B is the area of the floor, L into B is the area of the top. So twice LB, this is total surface area. So area of total surface area, but area of four walls. Area of four walls, which is given by twice L plus B, length plus breadth into height H. This is a square unit. This is the first formula we can use. This is known as area of the four walls or lateral surface in case of a cuboid. This is the first formula, area of four walls. Why? Because twice LH plus twice BH. H we have taken common, 2 we have taken common, so L plus B in the bracket and into H. Length plus breadth into H. Twice L plus B into H. So this is twice L into H plus twice B into H. Length of the area of the four walls. Two walls, the pair of two walls are similar. This wall is similar to the other one, the opposite one. And this wall is similar to this wall. If it is a rectangular shape of room, okay, box or room. So this is cuboidal shape. We have taken here. Now come to the point, what is total surface area? And in this case, total surface area. Total surface area will be equal to area of the floor as well as roof. That is also added up. Area of four walls plus this all lateral surface area. This is lateral surface area, or simply lateral surface plus area of base and you may say the floor, area of floor and roof, area of floor and roof. Okay, so this is what total surface area, which can be twice LB. L into B is the area of the base, area of the floor, and area of the roof is also the same, so twice LB. Twice LB is also added up. This is twice LB plus BH plus HL. This is a square unit. This is total surface area of all the six faces of the cuboid. Six faces means four walls and two floor and roof. So these are six faces of a room or a box, you may say, so, or cuboid. Cuboid. The room is a cuboidal shape sometimes because the rectangular shape is there. If it is a square, square base, square, all sides are square, then it is cuboid, cube form. It is cuboidal form. Okay, cuboidal form. And then volume. Third formula is what is the volume of this? Volume is calculated as the area of the base into height. Area of the base. Area of the base into vertical height or height into height simply. So here height is vertical only. This is area of the base is L into B into H height, LBH cubic unit. Then I talked about what is the length of the longest rod which can be kept inside the room, or we can say what is the length of the diagonal of a cuboid. So length of the diagonal of the cuboid is also the fourth formula. Let me write it down. The fourth formula is length of the diagonal of a cuboid, or in other words, the length of longest rod, which can be kept inside the room, Okay, inside the room. This is given by square root of L square plus B square plus H square. I described this, how this is described in a room. There is a double application of Pythagoras theorem. But in the base, this is the diagonal here. Okay, the diagonal of the floor and the room. So this length and breadth, right angle triangle. So L square plus B square equal to this H square, hypotenuse square. Then height, again this height is also added up. This is the longest rod which can be kept here. So the length of the rod or length of the diagonal of a room or of a cuboid is given by L square equal to that H square. Let me take the diagonal D square. So D square equal to L square plus B square plus H square, or D equal to square root of this L square plus B square plus H square. So this is the fourth formula. Okay, so these are the four formulae which will be applied or used to find the solution questions based on cuboid. Now let us talk about cube. Again, there are four formulae for cube also. Okay, so cube, second is cube. We have to talk about cube formulae. Again, there are four formulae which are used for cube. Cube is what? The base is a square. The floor of the room is a square type. Suppose this is a square type. This is a cube here. For example, ice cube in a refrigerator. Okay, this is a cube here. Let me take A, B, C, D. Okay, this is D dash, this is C dash, and this is A dash, this is B dash. Okay, so here all sides are equal. So this length, breadth, and height all are same. This is suppose A length, A height is also A. Because all are squares, all the six faces of a room, if it is room, cube shaped room, then cube shaped room if it is, then all the sides are, all the faces, six faces are squares of the same length or same side. This is A, we have taken height. So the formula here, again area of four balls, or known as lateral surface. Lateral surface is equal to 4 into side square. 4 into side square. Why? Because A square plus A square plus A square, all the four balls, one ball area is A square, other ball is also A square, the third one is A square, fourth one is also A square, so 4A square, 4 side square. Or this is 4 into A square if A is the length of the square, or square base, square floor, square roof, square side, I mean wall. This is square unit. Okay, again total surface area, second formula, that is total surface area. Total surface area is given by total surface area is equal to, because there are six faces, all are squares, same areas. This is 6 into side square. Simple formula you can understand. Square unit is the formula of 6 into A square, where A is the length of the side of the square, Okay, here this is 6a square unit area, total surface area. Then third one, volume. What is the volume? Now, because L, length, breadth and height both all are the same, A, it is A cube. Volume equal to A cube or side cube, cubic unit of side cube. Length of whatever side is there, the length is the whole cube, cubic unit. Okay, and the fourth formula which I applied there also, the length of the diagonal or longest rod which can be kept in a room of cube shape room. The length of the diagonal, it is known as length of the diagonal. Length of the diagonal is equal to square root of a square plus a square plus a square. As I did tell you, this is equal to a root 3. 3a square is square root of that. That means a under root 3. This is unit. This much unit. Okay, a square unit. This much unit. A is square root 3. Okay, so a square root 3 is the length of the diagonal of the room, length of the diagonal of a cube shape. Now come to the questions. Let me take questions. These are the 8 formulae I have discussed about of cuboid and cube. Now let us take questions based on cube and cuboid. Okay, so that I am talking about today. Let me take now questions. Now what is the first question? Let me check it. These are the 8 formulae which I discussed about. Now, next question is question number 1. Let me read it. Let me read the question first. Now it says the length, breadth, and height of a room are 4 meter, 3 meter, and 3 meter. Again, the two sides are equal. I mean, to length and breadth and height may be equal here. Length is bigger one, 4 meter. 4 meter, 3 meter, and 3 meter, respectively. The room is having 2 doors measuring 1 and 1.2 meter, 1.5 meter by 1 meter. This is a door. 2 doors, okay, 2 doors of this measurement. So we have to find out area of the door. Alright, 2 doors, area of the 2 doors, and one window, area of one window, measuring 1 meter by 1 meter. That means 1 meter square. That is the area of one window. What will be the cost? What will be the cost of whitewashing the 4 walls and the ceiling of the room? Ceiling means whatever the area of the roof is. What is the area of the roof? L into B, length into breadth. Reason? But that is the same area as of the floor. Area of the floor is L into B, length into breadth. This is the same area of the roof also, or ceiling also. We have to find out the total area of the 4 walls plus area of the roof, total this area. But because the window and the 2 doors are not whitewashed, their area will be subtracted from the area of 4 walls and area of the ceiling. Okay, area of the ceiling and area of 4 walls we have to first calculate and subtract the area of the 2 doors and 1 window out of, I mean, this total area of the 4 walls and area of ceiling. Then we will get the area which is to be whitewashed. Alright, let me take that. So here it is said that there is a cuboidal shape of a room. Okay, this is cuboidal shape room. Now it says length, breadth, and height. Length is 4 meter, 4 meter. Yeah, 4 meter, and this is 3 meter width. Height is also 3 meter. This is height here. Width is also 3 meter, and this is length. Okay, so A, B, C, D. Let me take A, B, C, D. This is D dash I have taken, C dash, this is B dash, this is A dash. Any, it can be taken PQRS, no problem. Any denomination can be done, A, B, C, D or whatever. Okay, that is not a matter of discussion. That is immaterial. We can take any denomination. That is not a matter of discussion here. Matter of question. Now come to the point. So it says like this. Now it says that there are two doors. Two doors may be here. Let me take. This is one door. This is another door. And the window is here. This is one window here. Now this window will not be whitewashed. Subtract these two rooms and one window is subtract. What is the area of the? Now let me check area of first four walls. Here let me write first what is the, and here L is equal to 4 meter, breadth is equal to 3 meter, C is equal breadth and height H equal to 3 meter. This is given to us. Here given, we are given here these things of a room. Okay. Length, breadth and height of a room are these, and area of a room is equal to 1 and 1.2 by 1 meter. 1.5 meter, 3 by 2 meter by 1 meter. This is area of the one room. So 2 rooms area is equal to 2 into, this is 3 by 2 into 1. 2 to cancel out, so this is 3 meter square. Area of the 2 rooms is 3 meters square. Why? Because 3 by 2 into 1 meter is the area of one room into 2, length into breadth into 2. Because there are 2 rooms here, 2 doors here. 3 meters square, this is area of 2 rooms, 2 doors. And the area of one ball, area of one window, not wall, one window is equal to, this is 1 meter by 1 meter. That is also given to us. 1 meter by 1 meter. This is equal to 1 meter square, or 1 only. So total area of 2 doors and 1 window. Total area of 2 doors and 1 window is equal to 3 plus 1. That means 4 meters square. Okay, 2 doors area is 3 meters square and 1 window's area is 1 meter square. Total sum of these two, these two different kind of things, that means 2